Okay guys, so I'm going to cover problem set 35. Your geometry is number 1 and number 30. Just so you know, I do all of my videos on Wednesday, so I'm wearing the same thing every day for 5 days. I know, I'm sorry. Yes, I do shower. Yes, I do take care of myself, but it's easier for me to get it all done on Wednesdays, so that is the day that I have chosen. But just now that we're clear about that, I wanted to just quickly remind you that yesterday we talked about greatest common factor, and remember that the greatest common factor is the common factor, the largest factor that two terms share, and the process for doing that would be to look at the smallest of the two numbers and start from there, and then determine what do they have in common, and you would do the same thing with the exponents of a variable. That being said, I want to draw your attention to the expression 2a parentheses x plus 7. Recall that you're going to use the distributive property to solve this problem. So that means you're going to take the 2a and multiply it times the x, and you will get 2ax. And then you're going to distribute the 2a multiplied times the c, and you would get 2a plus c. The reason that we are reviewing this is because now we're going to learn how to go from the expression 2ax plus 2ac backwards to 2ax plus c. So it's called factoring, okay? So we're going to take an expression and we're going to factor out the GCF. So it would look something like this. Look at example number 1. You have 2ax plus 2ac, okay? And you're going to start by, it says, now this is where you have to be careful and read the directions. If I say find the greatest common factor, all I'm saying is to do what I did before. So you're going to go like that, and you're going to say the greatest common factor is 2, and then you're going to say the a's, they have 1 in common, they do not share an x, and they do not share a c. So the GCF is 2a. Okay, so that's when they tell you to find the greatest common factor. But when the instructions say factor the greatest common factor, that's not factoring the greatest common factor. That's just listing the greatest common factor. So you need to know the difference, okay? So the way you start factoring the common factor, so let me write that down. Factor the GCF, okay, is you start by writing the GCF, and then you take it out of each expression by dividing by it. In other words, the inverse of multiplication, which is what you use for the distributive, is going to be division, okay? And then we know that we add exponents when we multiply, so since we're dividing, we would subtract them, okay? So a good way of thinking about it is take your 2a and put it under here. Put it under here. And you can see that those are going to cancel. Those are going to cancel. All you're left with is x. So this is a binomial. I'm going to put it in parentheses. The x stays there because that's what was left over, and then the sign is a positive and the c is what's left here. Now I can check my work by simply distributing. 2ax equals 2ax. 2ac would be plus 2ac, and you can see 2ax, 2ac, they do indeed check, so I know I did it right, okay? So let me do a couple of other examples. Remember, finding the greatest common factor just means what do they have in common, but factoring out the greatest common factor means you pull it out and you leave whatever is remaining in parentheses. Okay, let's look at number 2. It says a to the third x squared m squared plus a squared xm to the third minus a to the fourth x to the third m squared. Okay. All right, let's start. Let me move this over. Okay, let's start by determining, it says factor the greatest common factor. Okay, so we're not just going to list the GCF, we're going to factor it out, but we're going to start by listing the GCF. So I'm looking, and they do not have a coefficient in common. So when there's no coefficient in common, we know that they share a 1. So I'm going to stop by putting a 1. Now, you'll learn later whether or not to leave the 1, because 1 times anything is itself. For now, let's just put it just so we can have something for the coefficient. So the GCF is 1. Now let's look at the letters. We have an a to the third, a squared, and a4. So the a to the second power is the smallest of the exponents for my a's. So I'll put a squared. Okay. Now I'm going to do that with my x squares. This is x squared, x, and x to the third. The x is the smallest one. So I'll put it here. Okay. Now I'm going to do m squared, m to the third, m squared. The m squared is the smallest exponent. So that means my greatest common factor for the trinomial 1, 2, 3 is 1 times a squared xm squared. So now I can remove my 1. I know that I don't need it, okay? If there was nothing else in common, in other words, if the terms didn't have any letters in common or any coefficients in common, then you would have to leave the 1 and you would take away this, and you would only have 1 as a coefficient, which means your answer would be prime, okay? All right, so we're going to take that off. And now we know what our exponent is. Now in the other example, I said you can put it underneath. So I'm going to do that. I'm going to say a squared x m squared. I'm going to do that for each of them. M squared. And now you're beginning to see why the worksheet that we were doing that you guys had such a hard time with is important, because this is now allowing you to reduce your exponents. And remember, since you're dividing them, that means you want to subtract them. Now, there's 2 a's here and there's 3 there. 2 of them will cancel and you're left with 1 of them. First thing you want to do is start by writing your parentheses. Go and look at your terms. 1, 2, 3. So that means this is going to have 1, 2, and 3. Now this is a negative sign, so I'm going to change that to a negative. This is a positive there. So I had 1, 2, 3, there they are. Okay. I'm going to then say, okay, I canceled my a's on the bottom because there's 2 here, but there's still 1 left there. So in the first term, I have to write what's left. I'm going to do that with each letter. This is 1. So there's this one cancels, but I still have 1 left. So that goes here. And then these would be 2 and 2 cancel out completely. That would be m to the 0 power, which we know is 1. So we don't need to write that down. So that would just be ax. I'm going to do the same here. A squared would cancel with a squared. There's no a's left. X and x would cancel together. There's none left. 2 of these would cancel here. 1 would be left, so I would put m. So I can see that my middle term is m. And I'll do it again here. This is a squared, a4, there's 2 left. You notice what I'm doing is I'm just subtracting. 4 minus 2 is 2. Okay, 3 minus 2, 1. 2 minus 1, 1. Okay, 3 minus 1, you have to put a 1 here. That cancels. There's 2 left. So there's x squared. M squared and m squared would be like dividing 5 over 5. It cancels out to be 1. So those cancel out and you're left with nothing. So we can see then our answer is a squared x m squared parentheses ax plus m minus a squared. Now let me go back and check this just to verify that I did this correctly. Where's this one at? So, geez, they have a very long answer on that. So we have a squared x m squared parentheses ax plus m minus x squared a squared. So, oh, you know what? I didn't see the 2. I forgot to list it. So I have to put this one a squared right here because there was 4 and I subtracted 1, and then there was 3 and I subtracted 1. So this would be x squared. Okay, and that is your answer. I'm going to pause it. I'm going to go ahead and do another example for you.